The era of traditional enterprise application deployment is over. If we want to survive the next decade of automation, we have to stop building apps and start building vaults. We obsess over building firewalls while deploying autonomous AI agents that operate with legitimate network credentials inside our private perimeters. By transitioning to a highly connected web of agents, we have entirely shifted the enterprise attack surface. The concept of a network perimeter has collapsed. Security failures now originate inside the system, targeting the interpretive semantic layer of the AI itself. This vulnerability exists because of a single, unpatchable flaw at the foundation of modern AI architectures, known as instruction data ambiguity. Attackers exploit this flaw through agentic poisoning. To a transformer model, passive data and active instructions are processed identically through the exact same neural pathways. Adversaries embed hidden instructions into benign pages. When scraped, the agent executes them using approved credentials to exfiltrate data. Google researchers recently warned that the Common Crawl dataset, the foundational repository for most web-connected AI, is increasingly saturated with these dormant digital booby traps. This creates a massive operational time bomb. Traditional dashboards track token latency and uptime, but provide no visibility into the integrity of the model's underlying decisions. Because these hijacked agents use legitimate credentials and trigger no standard network alarms, the most devastating cyber attacks now look indistinguishable from normal daily operations. The danger scales exponentially with new interoperability standards, like the Model Context Protocol, which densely interconnects these agents across your entire enterprise stack. If one poisoned agent interacts with another, it can append malicious prompts into its own output. This triggers an autonomous infection cascade, known as agency propagation, birthing a self-replicating agent worm. Forensic frameworks now map this exact movement. They define agency propagation as a vector for lateral movement, where the worm exploits identity inheritance to spread through peer-to-peer AI communication pathways. This threat even extends into the foundation model supply chain itself. Microsoft research has detailed sleeper agents, malicious backdoors buried deep within a model's weights during fine-tuning, that lie dormant until they encounter a specific trigger. These cognitive exploits adapt their evasion strategies based on the specific enterprise environment, moving laterally through agents at machine speed. In a web of agents, relying on densely interconnected systems without deterministic guardrails ensures that a single vulnerability becomes an uncontainable enterprise collapse. Because transformer models process instructions and data through the same pathways, the concept of a network perimeter is now mathematically obsolete. We are facing a profound paradigm failure. To secure these environments, we must immediately pivot to neurosymbolic architectures. In this hybrid architecture, neural networks evaluate context, but only an explicit, auditable logical rule engine is permitted to execute an action. This ensures every decision is consistently aligned with corporate business logic. This requires absolute sandboxing via Wasm or eBPF to prevent cross-contamination, alongside cryptographic proof of provenance to verify the source of every instruction. To survive the transition to computational autonomy, enterprise leaders must abandon the illusion of application security. It is time to commit entirely to the deterministic physics of the vault.